In this video, we will solve some examples related to the combination. So in the first example, we have to prove that NCR is the same as N minus 1 CR minus 1 plus N minus 1 CR. So here is the proof. We have two different kinds of proof for this example. Number one, algebraic proof. So how to prove it? Just take left hand side, just write the definition. What is the definition of n minus 1 CR minus 1? This is n minus 1 factorial over r minus 1 factorial n minus 1 minus r plus 1 factorial plus apply the definition of combination on this factor as well. This is n minus 1 factorial over r factorial, then n minus 1 minus r factorial. Simplify these expressions, we will get n minus 1 factorial, and the denominator r minus 1 factorial n minus r factorial. And what about this? N minus 1 factorial over r factorial n minus r minus 1 factorial. Now we take the LCM of these two terms. So what's the LCM? Least common multiple of r minus 1 factorial and r factorial is r factorial. Least common multiple of n minus r factorial and n minus r minus 1 factorial. Because this term is bigger one, this is bigger one term, so it is the LCM n minus r factorial. Okay, here you will write r times n minus 1 factorial plus here you will write n minus r times n minus 1 factorial. We have just taken LCM. Now in the numerator, n minus 1 factorial can be taken as common. So we get n minus 1 factorial times this r and this n minus r. Okay, so the denominator is r factorial n minus r factorial. Cancel this r with negative r. You will get n times n minus 1 factorial, and in the denominator r factorial n minus r factorial. What is this? This is the factorial of n. This is r factorial n minus r factorial. What is this? This is the formula for NCR. So we have proved it. Now look at the combinatorial proof. In this proof, we will consider that a set A has n different elements. So by definition, NCR is an R combination from A. Now we will count all such R combinations S of A in two different ways. So look, every R combination S of A either contains 1 or not. So we will have two cases. So in the first case, we will consider that 1 belongs to S. Now we want to consider all the R combinations. Since 1 has already been selected, so we will subtract from N as well and from R as well. So the number of ways to form S is N minus 1, R minus 1. Because there are total N elements, we have selected 1 already. So we will not consider it again. Therefore, we have subtracted it from the whole number of elements as well, and from the uh, number of elements which we have to choose as well. In the second case, we will consider that 1 doesn't belongs to S. Since 1 is not in the S, but we need R combinations from A. Since A had n number of elements, now we don't need 1. So how many elements are remaining? They are n minus 1. So we will choose R combinations from n minus 1 elements from A. So the number of ways to form S is n minus 1 CR. Now we have choose exactly R elements from n minus 1 elements because we don't need 1. So we have two ways to find S. This is one way. In this way we need 1, and these are the combinations in which we don't need 1. So by some rule of counting we can find all number of combinations. The total number of combinations are the total number of combinations are the sum of these two. First one n minus 1 CR minus 1, and the second one is n minus 1 CR, which is proved. So now look at another example. So this example says that in how many ways can a committee of 5 people be formed from the group of 11 people consisting of 4 teachers and 7 students, in such a way that there is no restriction. Number 2, the committee must include exactly 2 teachers. Number 3, the committee must include at least 3 teachers. Number 4, a particular teacher and a particular student cannot be both in the committee. So here is the solution. So in the first part, since there is no restriction and there are total 11 people, and we want to make a committee of 5 of them, so we will use simply NCR. Here n is 11 and r is 5. So 11C5 is the same as 11 factorial over 5 factorial into 11 minus 5, which is 6 factorial. We will get 462. Now in the second part, we have to make a committee of 5 people in which there are exactly 2 teachers. But there are total 4 number of teachers and we have to choose 2 of them. So total number of teachers are 4 and we have to choose number of teachers which are 2. So the number of ways to choose 2 teachers from 4 is 4C2. And this is the same as 4 factorial over 2 factorial into 4 minus 2 factorial. After calculation, you will get 6. But we have only choose 2 teachers. We have not made a full committee until now. We have to choose 3 students as well. Since there are total 7 students and we want to choose 3 of them. So now the total number of ways to choose 3 students out of 7 is 7C3. So after calculation we get 7 factorial over 3 factorials times 4 factorial, and its answer is 35. Now we have completed the process of making a committee. So the half process is to pick teachers and the half process is to pick students. So we will use the product rule of counting. We get total number of ways to form a committee having exactly 2 teachers is the product of previous 2 results. The first result is 6, which is the number of ways to choose teachers, and the second result is 35. This is the number of ways to choose 3 students out of 7. So our answer is 6 times 35, which is 210. It is the answer of this part. Now in the third part, we have to take at least 3 teachers. Since there are total 4 teachers, so we can take 3 teachers or we can take 4 teachers. So we will find the number of ways in which we can choose 3 teachers, and then we will find the number of ways in which we can choose 4 teachers, and then we will use the sum rule of counting. So since we have to choose at least 3 teachers out of 4, so we have 2 cases. So in the first case, we have to choose 3 teachers out of 4. So the number of ways to choose 3 teachers out of 4 is 4C3, which is 4 factorial over 3 factorial into 4 minus 3 factorial, whose answer is 4. Since we have chosen 3 teachers, we want to make the committee of 5 people, so we have to choose 2 students out of 7 as well. So the number of ways to choose 2 students out of 7 is 7C2. Its answer is 21. So the answer of the first case can be obtained by the product rule of counting, because in the half part we have chosen 3 teachers out of 4, and in the half part we have chosen 2 students out of 7. So the total number of ways to form a committee is the product of these 2 parts, these 2 results. So the number of ways to form a committee containing 3 teachers are the product of the previous 2 results. The first result is 4, the second one is 21, so its answer is 84. Now we consider case number 2. So in this case, we will consider that number of teachers which are to be chosen are 4. Since there are total 4 teachers and we have chosen all of them, so the number of ways to choose 4 teachers out of 4 is only 1. So it can be denoted by 4C4. You can see that its answer is 1 because it is 4 minus 4 factorial. 4 factorial is cancelled out. 1 over 0 factorial, which is 1. Now we have chosen 4 teachers and we want to make a committee of 5 people. So we have to choose 1 student. Since there are total 7 students and we want to pick one of them. So we will use the formula 7C1, which is 7. So what is the answer of this case number 2? It is also the product of the answer obtained by choosing the number of teachers as well as the number of students, because we had to make a committee of 5 people. In one step we have chosen 4 people and in other step we have chosen 1 people. So the answer of both parts is the product of these 2. So we will use the product rule of counting again. So the number of ways to form a committee of 5 people containing 4 teachers is the product of 1 and 7, because 1 is the number of ways to pick 4 teachers out of 4 and 7 is the number of ways to pick 1 student out of 7. And the answer of this case is 7. Now we have to finalize the answer of this part, because in this part we had required to find the number of ways to form a committee in such a way that there are 3 teachers or there are 4 teachers. So due to our operation, we have to use sum rule of counting. So we will sum up the result of case number 1 as well as case number 2. So the total number of ways to form a committee containing at least 3 teachers means 3 teachers as well as 4 teachers. So for the 3 teachers, we have got 84, and for 4 teachers we have got the number of ways which are 7. So by some rule of counting we have added them, so our answer is 91. So in the fourth part he asked to make a committee of 5 people in which a particular teacher and a particular student do not come together. In order to solve this part, first we find the number of ways in which the particular teacher and a particular student come together, and then we will subtract these number of ways from the whole number of ways in which we make a committee of 5 people. So we will suppose that a particular teacher and a particular student are chosen in a committee. Since there are total 4 teachers and we have already picked one teacher, and there are 7 students, we have already picked a particular students. So the remaining teachers are 3 and the remaining students are 6. In order to form a committee, we have to choose 5 people, but we have already chosen 2 people. Now we need 3 people out of 9 people, because there are 3 teachers remaining and there are 6 students remaining. So we will pick 3 of them. So now the remaining people will be chosen from 9 whole. So the remaining 3 people of the committee will be chosen from the remaining 3 teachers and 6 students, which are 9 in total. So the number of ways to choose 3 people out of 9 is 9C3. So after expansion we will get 84. So these are the number of ways in which a particular teacher and a particular students are coming together. But we want those committees in which these people are not coming together. So we have to subtract these number of ways from the total number of ways of forming a committee of 5 people. Since the total number of ways to form a committee of 5 people without any restriction is 11C5, which we have already calculated in the first part of this example. Now we want to subtract these numbers from this total to get the number of ways in which a particular teacher and a particular students are not coming together. So the number of ways to form a committee of 5 people in which a particular teacher and a particular student are not coming together is the difference of 462 and 84. So our final answer is 378.